All right. Hello, everybody. Today we are having our last colloquium speaker as part of DRP Turkey. And today we have Aslihan Demirkaya from Amazon as our guest speaker. Aslan Demirkaya is a research scientist at Amazon. She's a part of Amazon Devices demand planning team. Dr. Demirkaya holds a PhD in mathematics from the University of Kansas, and prior to her current role at Amazon, she served as a professor at the University of Hartford. And her passion for promoting the accessibility of data science led her to play an integral role in the creation of the University of Hartford's data science program. And during her tenure at an AI company at Palo Alto, she even took the initiative to teach a data science class at the University of San Francisco. She also devotes her time to delivering lectures and organizing seminars on machine learning and deep learning. And today we are going to listen one of these lectures. She will be talking about her experience about applying math expertise in AI during her transition from academia to industry, which is a very hot topic these days. Dr. Demirkaya, you can take it away.
Hi everyone. Good morning to the ones who are in US and good evening to the ones who are in Turkey. And I know if anyone is attending from Europe, probably it's afternoon. Good afternoon to those ones. So I wanted to pick a cool title. I wanted to talk about my journey, how I transitioned from academia to industry, and I also wanted to include how I applied math in AI, data science, machine learning. So I wanted to, there was only AI in the title, but I added data science too, because I switched from math to data science, and then I also recognized that AI and machine learning comes with data science. So let's go to the next page. So my title, the first 10, 15 minutes, I'm going to talk about my journey from math to data science, how I switched, how I started with math and how I ended up at data science AI, and why did I pick data science, and what math did I use and am I using in data science. I'm going to give simple examples, just give you an idea how we can use math in data science, machine learning, or AI. And then we are going to talk about a little bit about black box models. And if we have any time left, I want to talk about some ethics in data science and AI, because it's a very cool topic. There are several conferences on this topic, but if we have any time left, if not, maybe next time I meet you, I'm going to go only about this topic because it's really cool. Let's start about my journey from math to data science. So a little bit about me. I studied industrial engineering and math at Middle East Technical University. I graduated in 2004. Then I went to Bosphorus University for master's degree, but I didn't complete it. I stayed 1 year, and then I went to University of Kansas for PhD. I stayed there for 6 years, and then I got my tenure track offer from University of Hartford. I didn't do any postdoc. And my expertise was partial differential equations. There's some detail I want to give. On my last year, there was a requirement for PhD students. We had to take some coding class. And all of my classmates were, they weren't taking it seriously. They just wanted to pass. But I really wanted to, I knew coding from industrial engineering a little bit. We took C, but I didn't have my own computer. And I didn't pass it with A, so it wasn't perfect for me. So I wanted to take it seriously, and I took my C++ class, and really took it very seriously, got the perfect scores. At the end of the class, I said, this is why did I wait that long to take a coding class? Because it was very fun. I really liked it. I liked the algorithms. I mean, they were easy, but coding them, I really had lots of fun. I said, I wish I did my PhD in coding. So my advisor, which Shefika knows, I talked to her, I said, I liked coding. And she said, if you like coding, can you code the simulations of partial differential equations? She said it's cool to support the papers with some numerical computations. I said, yeah, sure, why not? So I tried so it was my 5th paper last year. I simulated the differential equations, the waves. We were looking at the stability of waves, existing of wave solutions. So it was my first time coding these waves, how they travel, what's their stability. I found their eigenvalues using because on theory we know where the spectrum is, but when you code, everything is discrete and everything is visual. What I understood is I was a very visual person. When everything is on theory, it's nice, but it's hard to reach people. When you give talks, I don't know if you notice, but if even the mathematicians are not in your area, they get lost. But when they see simulations, they pay more attention. So I really like it for myself and for others. And I told my advisor, I said, I want to do this. I want to do applied math. And she supported me. When I went to University of Hartford, there was a professor at University of Massachusetts Amherst. He was a very well-known physicist. He was doing also applied physics and math. And I started collaborating with him. And we actually published, as of now, around 20 papers together, maybe 15 papers, but total 20 papers. And when I was at the University of Hartford, which is a teaching-based university, it doesn't have a PhD program, it doesn't have any master's program, but we have undergraduate students, really smart students who were willing to do undergraduate research with me. And we simulate. So I taught them how to code in MATLAB. So not C++, but I switched to MATLAB. And we wrote 3-4 papers together with the students where again we simulated the solutions. So I'm giving this detail because I want you to understand that coding is really important for the next career I'm gonna pick. So I'm giving you an idea what my background became in years. So I'm at the University of Hartford. I got my tenure. I was promoted to associate professor. And then, as you guys know, we can get sabbatical for either 6 months or for a year. So I ask for 1 year with some reduction in the salary. And at that time, my husband also was in data science, already in data science. And I was hearing a lot about data science. And our University of Hartford wanted to start a data science minor program because it was becoming very popular. And I'm going to tell you why it was becoming very popular in the next few slides. So I just wanted to add, because I had coding skills and also I was teaching almost every class. I was teaching from partial differential equations to real analysis, to linear algebra, to statistics. So statistics was the key for me in addition to coding. So these two, also my friends who started doing data science, they were telling me statistics and coding are really important. So I just told my university, I said, I'm gonna go in the direction of data science, we started a committee, and I said on my sabbatical, I want to learn more about data science. So in 2018 to 2019, I took my sabbatical. We moved to California for a year. So this was what we wanted, just stay for a year and go back, because I had a 10-year track job and I was already tenured. So during this year, I looked for programs, and there were a few. There was only one university in the United States at that time. It was University of San Francisco, which started data science program as a major program. So there were minor programs, or there were like some certificate programs, but only there was one, and in San Francisco. So it was really very new at that time. And there was one certificate program in data science at UC Berkeley Extension. So I did this, mostly this like for 2 years, and it wasn't online at that time. This was before COVID. So I went to the campus, and so this program is mostly for the people who are switching careers. My classmates were like, they were already working at some like tech companies, let's say as software engineers or business analysts, but they want to switch their career to data science because it was extremely popular at that time. Everyone wants to have some data science on their resume, because when you apply, it really made a difference. So but my aim was completely different. I just wanted to see the curriculum, what they are teaching, and I just want to copy a similar curriculum and teach it at data science. This is at the University of Hartford. So this is what I was, and I was communicating with the instructors at this program. What I noticed is all the classes offered, I already knew. I mean, they offered probability and statistics, which I was already teaching. They offered Python class, so I didn't know Python at that time. Or there's R. So these two languages, R was popular among the mathematicians and statisticians, and Python was popular in like computer scientists and software engineers. I knew how to code in, I took C++, I knew how to code in MATLAB. So R was very similar. So I started with R. I took R, but when you want to take some like neural networks, AI class, R is not a good coding language. At that time, it wasn't. So I took Python also. So I took one neural network, and this is where I learned that neural network is completely linear algebra almost. But of course, we didn't have any idea. At that time, I didn't have any idea. So when I took these classes, as a mathematician, I knew like details, algorithms, whatever they use, which I'm gonna show you. It was some easy, like very well-known equation we knew either from linear algebra or calculus. So all my classmates treated me as like a genius person because I knew, and I was explaining them the details. So they were like, why aren't you applying like Google here, Facebook here? You're so smart. I was like, I'm a mathematician. Of course I know, because I'm teaching most of these classes, but my coding skills are not as strong as you are. So I was still scared. Like I didn't have any courage to apply to these, high-tech companies. But what happened is I got the motivation from these friends, my classmates, who treated me as a genius person. I said, okay, I'm gonna give a try for another year. So I asked the University of Hartford to extend my sabbatical for another year for free. So they didn't pay me. They said, okay. So I started applying for jobs. And what I observed is when I was in for the ones who are in United States, I don't know if the market changed, but my time when I applied like 300 positions, 300, and then I only got maybe 10, 15 phone interviews, a few like campus interviews. So it was very tiny, and you have to wait for like a year. So it was very stressful for me. I mean, for the ones who, I know if you had that experience, we are going to talk in the next hour. But what I observed is I applied on LinkedIn with like one-page resume, that's it. And then so many people started calling me. And even I started applying for academic jobs in this Bay Area. Only five universities I applied. All of them called me because I put data science on my that introduction like introducing yourself and like short summary of yourself. One paragraph was about data science, and all the schools called me and they said what my experience is in data science. So they were only interested in data science, not my extra like close to 20 papers in PD. They just wanted data science. That's how it was popular. That's why I'm giving you like the hint. I said, okay, data science is like a diamond. So I started telling all my colleagues, look, this is the data science is so popular, like the ones who are graduating from their PhDs. I did witness a huge difference. So this is a summary of me. After like 2 weeks, I started applying on LinkedIn. I got several calls. Because I was from academia, I was a professor. They were kind of scared because I still hold my position. And the ones who were interviewing me were like, they had at most master's degrees. They were kind of afraid, like, because I'm the professor, when they interview, ask statistics questions, they cannot, right? Because, so I did see their hesitation. So some even recruiters told me, it's hard for you to find your first job because you are in academia, you spent so many years in academia. So I was like depressed for 2-3 weeks, but then an AI company in Palo Alto, they just called and I started November 4. So I started applying in like September, and November 4th, I start my first day. So it is in the center of in Palo Alto. For the ones who don't know about Palo Alto, it's the center of Silicon Valley. It was a startup AI company. They were writing algorithms, like they were writing AI in a new language, and that's why they wanted to go to every machine learning model, and because they're all written in Python, most of them, or C++, so they wanted to convert to their language. So they needed a mathematician who would understand the algorithms. So it was a great experience for me because I had a chance to go to each machine learning algorithm and what math is used in their algorithms. So I learned a lot, and I also benefited, of course, the company, although they changed their project a year later. I supported software engineers. So what I also observed is software engineers are great coders, but they really like forgot math after they graduated. So I gave lectures, math lectures to them. So I kind of gave, and then almost 2.5 years later, I started Amazon. I'm gonna talk later, maybe at our discussion section. So I talked a lot, why data science, why AI, but why did it become so popular in United States? I know it's also becoming very popular in Turkey. So this graph actually explains everything, because we know how to read this graph. In 2010, so this is the size of data in the world, let's say, and these are zettabytes, and I really didn't know what zettabyte was. I know if it is 2T, here there's 1T, maybe there's a typo. it's equivalent to trillion gigabytes. Like, it's huge. And look at this, from 2010 to 2025, there's this exponential increase. So what does this mean? When there's data, companies want to use it, but why do they want to use it? Because they want to serve better. They want to, especially, for example, Amazon is so obsessed with the customer satisfaction. Why are they obsessed? Because they want to increase their profit. Because when the customers are happy, they want to shop more on, let's say, Amazon or other platforms. They want to increase their profit, and of course, they want to grow. They want to make millions, billions of dollars. So, but who do they need? Because they have data. Someone should clean the data. They should use the data, apply some machine learning model. So they need anyone who can deal with data. Data analysts, data scientists, applied scientists. Now the name changed from data scientists to applied scientists, data engineers, anything about data, blah, blah, are very popular, still very in high demand. When you look at the these, sets, this is data engineer, this is data analyst, and data scientist is in the common set of these three. So it's expected that data scientists should know math, they should know statistics, they should know algorithms, which as mathematicians we do. So this is easy for us. Software engineering, these coding skills, if you are interested in data science, now the name is applied science, anything about data, I do recommend you to improve your coding skills. And data communication, which is because we spend so much time doing our abstract work, we sometimes, this is what I see among the mathematicians, we are less social as compared to others. And but data communication is different, but in general, this is also like an important skill. This is what I see at Amazon if you want to get promoted. So yeah, so as you see, we are data science should be in the middle. So in 2012, I just want to see when people started hearing about data science, data. It was this Harvard Business Review, that's a journal, in the October issue. This is what I remember. I was teaching at the University of Hartford at the time. The title was "The Sexiest Job of the 21st Century." And you can just Google and read the details. The authors, one is, I think this is a math professor. One is a professor in Boston area, and this Padel is, he worked as a data scientist in White House. So he's the one, this Padel is the one who gave the name data scientist. So you can search more if you are interested and read this. This is a really nice article. So I was 10 years later in 2012, in 2022, there has been a similar article, and the question is data scientist still the sexiest job of the 21st century? And the answer was yes. So in 10 years, it didn't lose any popularity. And the same similar authors. So when you look at the, so this is 2016. So there's a Glassdoor, which is, I don't know which one in Turkey the equivalent one is, but you can search for jobs, you can apply for jobs. When you search like the best jobs in United States in 2016, you see that number one is data scientist. In 2017, again, data scientist. So these are the years. So this is when I moved to Silicon Valley. It was number one. 2018, again, data scientist. Then in 2019, again, data scientist. So number one. Because of COVID, it became like number three. And then when yesterday I searched in 2022, data scientists became the third. And these are a special number two. I know it's very popular too. So, but still it is in top three. When we look at the like data scientist profile, someone made a survey in 2022. They looked at LinkedIn profiles of 1,001 professionals to add diversity, 40% from United States, 30% from UK, 15% from India, 15% from other countries. I don't know if Turkey is included here. And then they want 50% from like top 500 companies and 50% not from top companies. And then what they see is a data scientist. When I say data scientist, don't just assume data scientist, anyone in machine learning and in AI, like all complete, but whose job title is data scientist. So 71% they are male, they're bilingual, mostly probably I say maybe international. They only have 8.5 years as experience, and it doesn't mean in industry, including PhD. 90% know Python or R, and 80% either have master's or PhD, and they're only data scientists for 3.5 years. So I just want to show you how new they are in this job. And when we look at the area of academic studies, I want to show you statistics and math is 16.3%. So this is not a small amount. And as you see, it's very uniformly distributed. Economics, engineering, natural sciences. I see people from physics, even like I met people from political science. So, and as you see, computer science, 18%. So almost equivalent to statistics. And when you look at the years of experience, most of them, the median is like around 3 years. So this is a very new, but this is as of 2020. So now we are in 2023. So then add 3 years to each one, approximately. Shouldn't be linear. Okay, so this is all about my journey and why it's so popular. And now I'm gonna check my time. Okay, we have half an hour. And math in data science. So, okay. So I'm gonna start with a easy easy question. So I just made this up. I said I like house data sets. It's like easier to understand. This is the example I give in my lectures. So let's say we have a very simple house data set. Only let's say we have 6 rows. So we have room number, we have age of the house, we have its square meter, and we have its price. So I made these numbers up based on the sahibinden.com. So let's say we have 2 rooms, age 30, 175 square meter, and then let's say it's the data says it's 6.2 million Turkish liras. Now my question is, given room number, age, and square meter, can you write a function that gives you the price? And now you can talk. I want these part to be interactive. Okay, I'm just writing, I'm asking you in the exam, like, can you come up with a function? exactly, I'm gonna enter these values, it's gonna give 6.2, I'm gonna enter 3, 15, 120, it's gonna give you 7.5. Is it possible? Can we write such a function?
Maybe we may not be able to write an exact function, but
Yeah, I'm asking an exact function, not approximate. Can we write? I mean, I do remember some polynomial functions, right? Passing through 230. Do you remember like x minus 2, x minus? I mean, we can come up with like really high degree polynomial, and then we can solve this. We can also find an approximate function too. Approximate is easier, but it should be possible, right? I mean, do other people agree? I mean, I think it should be possible to write. I can write a polynomial function that's gonna give exactly these values when we enter these. However, it's not.
Maybe we can use something like Lagrange interpolation.
Okay. Yeah, I mean, it should be possible. This is, but I'm not interested in the exact ones. Okay, I'm interested, none of the people in data science are interested. They don't even want an exact function. It's not even good to find an exact function. We have to find some approximate function. So our aim is to come up with a function f that's going to give you these values. And my claim is we can find, but if we increase the columns, let's say we add more columns, like more features and more rows, but I'm not saying like 1, 2, 3, like millions of, assume we have millions of data, millions of rows and thousands of columns. Function that's gonna give the price, that's not possible. It's not. Even like it's possible, let's say we find, we shouldn't find because there's, it's a separate topic, overfitting and underfitting concepts, which I'm not gonna go, I don't want to spend any time on that because I just want to focus on the math we are going to use here. So data scientists, machine learning people, AI, they have some data and they want to fit a function that will use the independent, they are going to call these features as independent features, and they have these different features, so they want to find price, in this case, is a function of other features. Why do they bother looking for a function that's going to give the price? The reason is, for example, sahibinden.com or Zillow, let's say Zillow in the US. Let's say I am the seller, I want to sell my house. I am curious how much money should I put on Zillow or sahibinden.com. If I know this function, right? Let's say I have 3 rooms. I have an apartment. Maybe mine is not 25, but 21. Maybe the location is in Izmir and square meter is, let's say, 87. I just want to see how much should I put on that platform. So all our aim is, all machine learning engineers, all these companies, they want to predict the unseen data. So this is the aim of finding that function. So there's this seen function, they call this like train set. They want to fit a function to their train data set, and then they kind of test their function, how their function is doing on a test set, and then they say, here is your function, use this function, and this is what all the companies are doing. So how do they come up with the prices, let's say on Amazon or on Gitti Gidiyor or Hepsi Burada, so these platforms, they use some kind of algorithm. They use a function, they put all these feature values. Feature values are these independent variables values, and then they come up with a price or whatever their dependent variable is. So first thing is how these algorithms work. When we look at the algorithms don't like strings, these let's say letters, words. They like numbers, most of the algorithms. So either a data scientist has to encode these variables. So these variables are called as categorical variables, like Istanbul, Ankara, right? We have to convert them to numbers. So the algorithm is gonna apply right in the function should have any words. So how can we change these to numbers? There are several ways. At least I know like 25 different methods that will change this into a different number, like feature. One way, easy way, which is taught in data science classes, is one-hot encoding or binary encoding method. So if instead of house type, we change this feature to if it is an apartment or not apartment. So if it's an apartment, put 1. If it's not an apartment, put 0. So everything becomes 1 or 0. So this is one way. The location also should change. We can similarly add if it is Istanbul, if it is Ankara, and then there is no need to add a feature for Izmir. If it is Istanbul, we put 1. If it is Ankara, we put 1. If it is not Istanbul or Ankara, we put 0. It means it's Izmir. So this is kind of one encoding method. Or we can just use another method, which is ordinal categorical method. We just assign some numbers. If you see Istanbul, put 1. If you see Ankara, put 2. If you see Izmir, put 3. So this is another way. Again, I can give you several different methods, but we have to change them to numbers before we apply any kind of algorithm. Okay, so this is called kind of pre-processing step. There are several pre-processing steps. Cleaning, if there are cells, again, algorithm is gonna fail. So you clean them, you remove them, or you replace them. You change the categorical to number valued features. And then now there are several machine learning methods, but I'm gonna talk a little bit about an ANN, which is artificial neural network. So this is an image I found after I searched Google. So you are gonna see lots of neurons when you search neural network. I had a friend from like my almost elementary school years. She's also working at Amazon. I was taking this data science certificate program, and we were driving, and she was working at Amazon in Seattle. She was visiting San Francisco, and she said, "Aslan, do you know there's this? I went to a talk. It was on neural networks. It's just linear algebra, just matrix multiplication, and because they want to have a cool name, they call it as neural networks. At that time, it didn't make sense to me. Like, what do you mean matrix multiplication? But after I took that class, like the next semester at Berkeley Extension, and after I went inside the algorithms at this AI company, I did see that neural networks is actually only linear algebra and applying the several linear, nonlinear functions, and then some calculus, and that's it. So inputs to this neural network, these arrows are actually matrix multiplications, these arrows. And hidden layers are some nonlinear functions applied to the matrix output after you multiply them, apply some nonlinear functions, again multiply with a matrix, and then apply a nonlinear function, multiply by a matrix. You do this like millions of times if you want a black box model, and then the output. But we'll go in more details in the next slide. So inputs are feature values, house number, room number, age, blah, blah, and the output is going to be the price. So here is how it works. Just a simple one. I try to make it as simple as possible. So these are inputs, are feature values, x1, x2, x3, xn, let's say, and feature values. And this one actually represents the bias term. It's like a constant term. So you multiply these inputs by a matrix A, okay? And this A depends on the dimension of X, because I want to pick a simple example. So let's say our feature space is just one, like n1, n2, so this is just a vector. So A is gonna be just 1 times 1 times n size. I try to make this simple as possible. So I'm multiplying this vector by a matrix A, and then I'm adding the constant term, which is called as bias term, and I want that result to be as close as to the target. What's the target? It's the price. So T represents for target, Y is the output of my neural net. So how am I going to define this close? So this is where we have to define close means what, and what is A and what is B. So this is the key part. So let's go back to our example. We have room number 2. So here the bias term is here. Sorry, I forgot. There should be a bias term here for B. Room number is 2. X1. So next is 1. Age is 30. Location is 1. Square meter is 175. So these are the first rows feature values. So when I give this, I'm going to multiply it by a matrix, and I'm going to add this bias term. Let's call the result as y1. I want this y1 to be close to 6.2. So what are unknowns here? I don't know anything about A's and B's, and of course y1. So maybe you heard about the weight. So when you search for neural networks, you are going to see weights. So the entries of a matrix and the bias term are called weights in the neural networks. We have to find these weights. And of course, we have to define what these, in which norm they are going to be approximately equal. So the next one is the second row, 3, 0, 15, 2, 120, right? And I want it to be close to 7.5. So now I'm having a system of equations, but these are fixed, right? A and B, they are fixed. I'm trying to find the best weights that is gonna be closest to 6.2, 7.5, and similarly, I'm gonna repeat it to millions of rows. So when I said close to, one popular norm is this L2 norm, which we know. So we do minimize, right, the sum of squares, square differences, which is the L2 norm. So we want to minimize this error in L2 norm. So when we write the system, right, the first one is A11 times 2, A12 times 1, and then the second is A11 times 3, A12 times 0 plus B. So I have a system of equations. So Y1 is this, Y2 is this, and what am I trying to minimize? This minus this, squares, sum of squares, this is what I want to minimize. So how do I minimize it? Minimization, we all took calculus 3, and we mostly were instructors in that class. If you remember this gradient descent algorithm, this is what actually software engineers only know. When you say like, what math do you know? They say gradient descent. What's gradient descent? Now, here the idea is what coders type. They say, let's start with a random A11, A12, A13, A14, A15, and B. Randomly picked, just initialize. Let's say 1, 1, 1, 1, 1, 1. And then what they do is, what the code does, once you plug in these values, it calculates L, and then the aim is to decrease L. So how can I perturb these initial values 1, 1, 1, 1, so I decrease L? So for example, I mean, you cannot randomly play around 1, 1, 1, 1, 1. You have to smartly pick values that will guarantee that the next iteration will give you less value. L is called as loss function. So here calculus helps. This gradient descent algorithm guarantees that in the next iteration, when you update your weights, for sure your loss is going to be less than the first one. So here is the approach. What does gradient descent says? If you walk in the negative direction of the derivative, then you'll decrease L the most. You'll decrease the function the most. So this is my weight, my initial weight. So let's say 1. This is my initial weight 1, because this is the updated one. This is how the coding, so this is the initial one. Alpha is the learning parameter. It depends, it's randomly, its default is 0.1, but the user picks the best alpha. This is the partial L. So we differentiate loss function with respect to the weight, the first A11. And let's say this value is 0.1. Let's say alpha is also 0.1. Then my next A1 is going to be 1 minus 0.1 times 0.1, which is going to be 0.99. So in the next iteration, I'm going to pick that value. I'm going to repeat this for each weight. And for sure, in the next iteration, my loss is going to decrease. And this is, how do we find partial L, partial A11? This is where we change rules, right? It's partial L because L is a function of T and Y. Y is a function of A11. So in order to differentiate L with respect to A11, we differentiate first with respect to Y, and then with respect to A11. So we apply chain rules. Okay, so this is an idea. This is where we apply calculus. This is really difficult for software engineers because they already forgot. I mean, they took calculus and they forgot, but because we teach these classes, it's easy for us to apply and to understand. So Lightbox models are when we, so I showed you only one linear layer. So what did we do? We had input variables, and then I picked like the easiest matrix, m by 1 or 1 by m. And we had output. But it's a linear model, and it doesn't satisfy AI people. It satisfies the business people because they like explainable, easy models. Because when they put millions of dollars, they want to see what kind of model they are having. They want to understand the model, but it doesn't satisfy the people in Silicon Valley in AI because the model is too easy, it doesn't perform well. So in order to estimate it with a better function, you cannot just have one linear function or just a matrix. You cannot add two linear next to each other because multiplication of two matrices is another matrix. Again, it's a linear. So what they do is like a sandwich, linear and then non-linear layer. When I say non-linear layer, there's some like well-known non-linear functions like sigmoid, hyperbolic tangent function. So they just add non-linearity. They don't have any weights. And then they put another linear layer, another non-linear. So it should always be a linear, non-linear, linear, non-linear. So when you repeat this like thousands of times, of course you'll have thousands of weights here, and every time you apply gradient descent, your weights will be updated. So there will be a forward pass, backward pass. In forward, you are gonna find the loss, and then you are gonna take the partial derivatives. This time you are gonna differentiate. So L is here, L is a function of these y's. You have to apply this chain rule several times. So dl over this function times this function partial this function partial this matrix times partial this matrix times partial this function. So you're going to apply this chain rule so many times that we cannot do this on the paper, and it takes time. So if you have several weights, you wait. I mean, it takes time your code to run. Of course, this is where the coders write really, like they add optimization methods and make it faster. I did also write this algorithm from scratch. Of course, mine was really slow because I didn't add any kind of optimization algorithms. But I was able to apply all these chains. So Blackbox model, what happens if there are millions of weights? We cannot understand, we cannot explain it. For example, BERT, which was the language model, NLP, in 2018, they had a neural network and they had 24 encoders. Encoders did different architecture, but I just wanted to show you that their large one has 340 million parameters weights and 110 million weights in the base one. So at every iteration, these are updated. So what happens is it takes like months to train a model. So they trained a model and then they shared their trained parameters. So other companies use those trained parameters because it's really hard to, it's not possible to train it on your local computer. You should have like huge computers and you should wait. So, but they applied gradient descent that, of course, there are other techniques. Gradient descent is a first order algorithm. if you apply second order for some loss functions, not all, you can get really like fast results, which is generalized linear models, least square methods. These are all second order. It's another, again, calculus. They use Newton's approach. Again, we can understand mathematicians, but I gave a lecture on that topic, and it was really hard for software engineers to understand it. But for us, it is not. Again, there's so many black box models, just I'm giving the famous ones. There's tree-based models, which is, there's like a tree. It looks like a tree. So the algorithm is a sum of piecewise defined functions. So let's say these are features. So age, if age is less or equal to 37, go in this branch. If it is not, go in this branch. So if you are here, then you are going to check this feature. If it is less, you go here, you go here. So what happens is you start here, and then if you end up here, then your prediction is, and this is a classification problem, instead of a number, you just say healthy or patient, and then you say it's healthy, for example. This is explainable. I can explain it to you here, but assume you are adding thousands of trees in this form. Like, how can you explain it to your manager if you have a sum of thousands of trees like this? So it's not also explainable. If anything you don't like occurs in the model, you cannot explain it. Okay, so I'm gonna check my time. Oh, it's 1 hour. Okay, I'm gonna finish in, can you give me 5 more minutes and then I'll finish?
Yeah, you can,
Okay.
if
All
you
right.
can wrap it up in 5
Yeah,
or 10
yeah.
minutes, that would be great.
Okay, so black box models are, why do people prefer black box models? Because they are very accurate, they give great, their performances is great. Why, what are the disadvantages? They are not interpretable, explainable, and it can affect the human lives. And there are some discussions which we can go through. This a big shot in AI, Jeffrey Hinton. He started this some time ago, like 2-3 years ago. He asked that question. So suppose you have a cancer and you have to choose between the black box AI surgeon that can explain how it works, but has 90% cure rate, and the human surgeon with an 80% cure rate. So do you want AI surgeon to be illegal? So there were questions like, should it be legal or illegal? I know what you prefer. If you were in that case, I'm gonna change the question where we can discuss, do you prefer to have the AI surgeon or human surgeon? There's this, this happened in 2019, November 19th. We see that journal which talks about it's a magazine that focuses on how emerging technologies affect culture. I don't know if you heard about this Apple Card. Their model were biased against females. All the feature values are the same for the wife and the husband. Everything is the same, but for the wife, it gives, let's say, at most $5,000 credit, but 20,000 credit to the husband. And the wife was like, why is this Apple Card not fair? And then they checked their model, and it took them several days to understand why. Here, the response from Apple just added confusion and suspicion. No one from the company seemed able to describe. I don't know what the why algorithm is giving that result. So because they cannot understand millions of weights, which one affected which. And then, I mean, these are really, okay, this is my last slide. So black box models are still there are lots of discussions, very hot topics. Should we trust them? because you can, if you just trust black box model, and if it is not anything dangerous, you can have the therapy for no reason. There are still self-driving companies. They still cannot do like a great job. Still, they fail. For example, when they see this stop sign, it happened that don't stop and then just drive. And is it fair? Again, this was lots of, there had been several discussions on this. Even you, like from the name, you can, the model can tell you are female or you are not white man, then you may not pass the first test, because this is how the recruiters reach you. First, the algorithm picks your resume and then it goes to the recruiter. Okay, so I'm gonna stop here. I'm not gonna go through the ethics because it's another like really important topic. But yeah, I'm gonna stop here. I'm gonna unshare my screen if you want, or do you wanna, if you have questions?
Yeah, we thank our speaker. Thank you very much.
Okay, let me unshare.
Anyone?
So
Okay.
I'll show you.
Does anyone have any questions about the talk?
Recording kapatıyorum. Öyle.
Or about them?